Alright guys, this session is going to be on electrochemical cell. So over here we're going to have two electrodes. We have the anode. Let me change my font. I'm just going to stick with black, right? Cool. So right here is going to be the anode. And in this situation, the anode is going to be zinc solid. Right here we have the cathode. And this is going to be copper solid. Now, inside these are in like little beakers, I guess you can call it, and there's liquid, and the liquid inside this beaker is going to be ZuNO3 2 aqueous. Then in this one, it's going to be CuNO3 2. Alright, so there's some important facts to know. What happens inside the anode, or the anode section, is oxidation. And what happens inside the cathode is reduction. So, let's write this formula out. I'm going to write it up here. I'm going to have it pointing to here. Oxidation is what happens here. And oxidations look something like this, right? Zn solid equals Zn2 plus 2 electrons being lost. Alright, so then we have over here, that's an option, we have reduction occurring. So now we have Cu2 plus 2, I'm going to write that a little bit better for you guys. Let me just find the hand. Oh, wrong one. Screwed that up. Oh, let's see. What's reduction going on? Let me just highlight that there. Reduction, and we have reduction looking like this. Cu2 plus 2e minus Cu. Alright, so these are balanced. This equation right here, the Zn and that, it's part of a chemical equation, and I'm not going to go over balancing it. It's not really worth it. But we figured out which one was the oxidized and which one was being reduced, and then from there we got this value right here, the Zn right there. Then we found this one, and we know that reduction occurs in the cathode, so that's what we labeled here. Oxidation occurs here. So, in the basics of this, what is happening is the anode is more positive than the cathode. So positive attracts a negative, right? So everything that's negative from here and here is going to the anode, and then the anode is going up here because electrons are what travel, not protons. So then all the electrons come here because it's more positive here, so it's attracted, and then it goes up, 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 up. And this is supposed to be a little light bulb. So it's lighting, then it goes here, and then it comes back down. Now, let's look at the formula. Oxidation, oxidize. Zn solid loses electrons, so that's why it has plus 2e, it lost 2 electrons. Reduction, over here, it's gaining 2 electrons. So think about it. If this is losing 2 electrons, comes over here, and it's plus 2 electrons, because see, this has Cu2 plus. So let's redo that a little bit. The electrons from here, or anything negative, any anions from here, and here get attracted to the anode. Then they travel, so we have 2 electrons being taken from here, and anything negative from there coming over here, going up, 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 making some sort of light, or motor, whatever that is, and coming down, and this is missing 2 electrons until it becomes a solid, but then it gets the 2 electrons back again, and then when those 2 electrons come back, Cu2 plus 2e becomes Cu solid. So now this is Cu solid, and then you'll start to see a precipitated copper. And I believe that's what you guys did during your lab. I was unfortunately not able to be there, but this is the basics of what is happening. Now, some basic notes. Anode is more positive. The anode is more positive, and the cathode is more negative. So charged ions that got attracted to the positive charge anode go through the wire to the cathode, then gets added to the solution that makes copper solid.